Bismillahirrahmanirrahim. Students, welcome to virtual session of week 12, System Analysis and Design. If you can hear me properly, please raise your hands. Okay. So we were talking about program design in our face-to-face class, and I'll continue, with my lecture first. And after my lecture gets over, you can ask me questions which you want. So we were talking about program design. I told you that program design is to create instructions for the programmers, and we follow a top-down modular approach in which we begin with a big picture and we gradually add details. And program design documents, which is the outcome of this program design activity, is all the structural charts and specifications which are needed by programmers to implement the systems. So we give program design documents to our programmers who start writing the implementation part of our system. So we talked about analysis phase, design phase, and physical process models, and then I told you that we convert our logical data flow diagram into physical data flow diagram, which contains the same components as a logical DFD, and the same rules as were applicable in logical DFDs apply over here as well. There are 5 steps to make the transitions. I told you that the step 1 is to add implementation references using the existing logical DFD. You add you think in terms of implementation. Then you draw a line to separate the automated parts of system from the manual parts. So you make a human-machine boundary. Then you add system-related data stores, like how you have implemented them in your systems. So you add them. Then you update the elements in the data flows. You give the real names as which you are going to use in your implementation. And then you update the metadata in the case repository. So you update the data because now you are concerned with the physical characteristics of how you are keeping the data. So you update them in case repository, and you come up with your data flow diagram. This is a physical data flow diagram which shows the how part, like find CDs, the C program for this. So you make a program for all of these processes mentioned with 1.1, 1.2, 1.3. In this physical DFD, now you are mentioning the data stored with the real names, like ASCII. D5 is ASCII order history file. D4 is Oracle hold table. Then D2 is Oracle inventory table. So in this way, you specify that what are you add implementation related details, like to find stored, you get store locator input form, and you give output as store location report as output. So as you can see, all the arrows are now one labeled, and we are now in the implementation part. So we are linked to the implementation part. Then when you are designing programs, there are certain things which you have to follow. First of all, resist temptation to write code too quickly. System quality is enhanced with top-down modular approach, and program design document is the final deliverable of this task. And I give you an example of top-down modular approach, that first you look at the big picture and then you start exploring it further and add more and more details as you move to the downward level. Now I told you about structure charts, that the structure charts are made for every data flow diagram, every physical data flow diagram, and it shows all the components of a code in a hierarchical format. You represent sequence, selections, and iterations. And this is an example of structure chart in which the process was create student grade listing. So now you can see here that get student grade record is giving output to create student grade listing, and what are the outputs? It is giving student grade report, and it is sending a control as well, control couple, which indicates the end of file. So I explained this structure chart in class, so I'm going to skip it now. Then I told you that these are some of the elements which you use in structure chart: module, library module, loop, condition lines, data couples, control couples, off-page connectors, and on-page connectors. Then I told you that the processes in the DFT tend to represent one module on the structure chart, and there are some afferent processes, central processes, and efferent processes. So afferent are the one which provides input to the system, central are the one which perform critical system operation, and efferent are the ones which handle system outputs. And then I told you about the structure charts, that there can be transaction structure chart, and there can be transform structure chart as well. And these are the how they look like. So the above one is transaction structure chart, and transform structure chart. So how you build a structure chart is first you identify top level modules and decompose them. You add control connections, you add couples, data couples and control couples both, and then you review and revise it again and again. Then I told you about cohesion and coupling. That cohesion is the connectivity of components of the components within the module, that how strongly they are connected with each other. And coupling is the relationship, represents the relationship between two modules, that how they are interrelated or connected with each other. Then I told you about types of cohesion, that cohesion can be functional. If it is functional cohesion, it is better. Sequential means in one output from one task is to be used by the next, so it is sequential cohesion. If all the processes are sharing the same input or output, it is communication cohesion. Then procedural cohesion. So these are different types of cohesion which exist, which may exist. Excuse me. And this is the cohesion decision tree. Does the module do one thing? If it is doing one thing, then it is having functional cohesion. If it is not, then we have to identify that how their tasks are related. Is the sequence important? If the sequence is important, then it is sequential cohesion. If the sequence is not important, but so then there is no then it is communication cohesion. If the sequence is important, then for flow of control, if sequence is important, then procedural cohesion, and if it is not, it is temporal cohesion. If they are not related, then they may have logical cohesion or coincidental cohesion. Then the processes with this low cohesion are dealt with a technique which is factoring technique. Then these are the types of coupling, with how two modules are related with each other. The type of couplings are data coupling, stamp coupling, control coupling, common coupling, and content coupling. So data coupling is the one where modules pass fields of data or messages. So they are passing, sharing data. This is the strongest coupling. Or if the modules pass record structure, then it is stamp coupling. If module passes a piece of information that intends to control the logic of other, then it is control coupling. If modules refer to the same global data area, so this is common coupling because they are sharing some data. If modules refer to the inside of another module, this is called content coupling. Now these are the few examples of fan in and fan out. So as you can see here, then in the first figure, you can see that the fan in for this is 3, fan in for 1.1.1 is 1, and the fan out for pay employee is 1, 2, 3, 4, 5, 6, 7, 8. So fan out of pay employee is 8. So so this is not good. If the fan out of is too large, so what you do is you divide this into further sub processes, like you place some processes under some others, like you have placed calculate salary, calculate employee salary. So you have made a upper module calculate salary, which is keeping calculate employee salary, employee benefits, calculate then structure will declare. So you are keeping it in one module. So in this way, you have reduced the fan out of pay employee, and you have wired in this way. You can have quality checklists. Library modules have been created wherever possible. The diagram has a high fan in structure, so control modules have no more than 7 subordinates. Each module performs only one function, so it's a high cohesion. Modules sparingly share information, which is loose coupling. So just wait for a second. Okay, I'm back. So I was telling you about quality checklist, that these are some checks which you can apply on your structure charts. So if you see that your structure charts are satisfying these things, and your the physical DFD satisfying these things, so this is the qualities you can check that whether you are giving your right documents to your programmers. Then you have to make program specification. To make program specifications, you know, now you have to give some documents to your programmers for implementation. Your structure charts are ready. You have checked them against this checklist. So these are very important points. Like each module, suppose if you look at number 4, each module performs only one function. It means high cohesion. So we should not keep multiple functions in one module. So the functional components should be separated. The control components are passed from low to high. Each module has a reasonable amount of code associated with it. If there is a module which is not doing anything, just a few tasks need to be done, then you can merge those modules. So these are the quality checklists. So after you have performed quality checklist as well and your structure charts are final, now you need to write program specifications. There is no standard approach to write program specification. It just includes the program information. So programming will be made for every process. So if the program is being made for one process, then you can write the specifications of that program. Note events that trigger actions, list inputs and outputs, what type of inputs this process will be taking, what it will be generating. So for every program you have to, and sometimes you write pseudocode as well. So are you familiar with pseudocode, what it is? So you may be familiar with, like, pseudocode is in English language. You write a program which can be translated in any programming language. You present additional notes and comments if you want, or if you have any requirement, like requirements from users or your requirement or from some other, you can mention over here. This is a program specification form, for example, for ABC systems. So you mention that in which language you have to write, what are the events, what are the inputs types, who will be using it, and if there are any node, pseudocode, or any information that you want to mention. So this is one sample. This is how pseudocode looks like get CD info module except CD, this is required except CD and then you have to return. This is pseudocode, not listed in any programming language, just in plain English-like language, which can be translated. And this is process description. Sometimes you write in this way. Like in analysis phase, you write specification with structured English, in structured English. In design phase, you write instead of structured, now you write in pseudocode and you add relevant information as well. So as you keep on moving from analysis to design phase, your things gets matured. So the same module which was mentioned in analysis phase now have more details about inputs and outputs in the design phase. The structure chart shows all the functional components needed in the program at a high level. Components of a structure chart show sequence selections and iterations. So need to follow design guidelines regarding cohesion, coupling, and fan in, fan out. And you need to, once you make your structure charts, you need to check them against the quality checklist. And if it gets satisfied, then you can write your specification and give it to your programmers for implementation. prepare detailed specifications, and show all the important programming structures. That's all from chapter 10. So that's this week's contents. I hope you have seen the video placed in the on the blackboard for this week, and you have read the article which is there. So if you have not, please do so, because it's very important that you follow the weekly task, because we are quite near the end of semester, and it's week 12. Only 2 weeks are left. So it's very important that you follow the weekly breakdown and read all the weekly contents. Okay, my lecture is over. Now, if you have any question from these contents or the contents we have studied in class or about anything, you can ask me now. Students, thank you. I am turning my microphone off, and I am available. So I'm available for your question till 6 p.m. So if you have any question, you can just type in the text panel, chat panel, and I'll answer you over there. Thank you very much.